Hello everyone, and today we're looking at a Williams WPC driver board. The problem with this one is basically that a load of coils and lamps, well, I think it was more the magnets and the flash lamps were locking on, so we need to investigate that. The front of the board looks fairly good, but the back of the board has some hackery. So we've got that there, that there, that there. So we might have to clean a few things up, make sure it's nice and reliable, good connections on there. So let's start by finding the fault. And I forgot to show you that this capacitor here is actually melted. Looks like that's blown its safety cap and leaked out all the electrolytes. That needs cleaning up. And obviously this is going to be the sort of root cause area of the fault. So our bridge rectifier at BR4 had a leaky junction which will have been putting through a fairly high AC ripple, which will probably cause the capacitor to fail. So we've got a modern higher rated bridge rectifier, which is a 400 volt 35 ampere, so that's going to go in there. We've also got a high quality Panasonic 105 degree long life capacitor. These are good, this will last absolutely years. I always use this brand. So we'll fit those in, and that should be a start towards fixing that 20 volt power supply section. Okay, I've reflowed these connections where the fuse holders are, as they were quite poor. And I also need to do a bit of repair here. Someone's sanded these tracks down here for some reason, so I'm just going to put some solder over there to strengthen them up. I think they might resolder these connectors as well, just to make sure. Not too bad, but yeah, we'll do those as well. And then we need to have a look at what all this mess is here, what's going on here. Has this been done correctly? Looks a bit bodgy, so we'll just test it all out. On second thoughts, this connector actually looks pretty poor condition. Not well, maybe that one as well. Definitely going to replace this one here, that's burnt, so that's not going to be making good contact at all. I guess I was just about to desolder Q30, because I'm going to replace all the transistors on the coils that were affected by this problem. And I've just noticed that this one here, it's got all sorts of gunk and shorting crap all over it, so I'm going to have to desolder that, probably replace that, clean that up as well. Now we can see that the GI connectors have previously burnt and been replaced, but the solder that's been used is all sort of crystallised and gone white. There's also lots of yellow flux on it, so I'm going to clean all this up, probably suck all that solder off and put fresh solder on. Because that's I don't know what the hell solder this is, it's horrible. Okay, as you can see, I've removed all the old solder, cleaned up all the horrible flux, and I put brand new fresh solder on, and it got nice shiny good solder joints there. And it's just drying now. I've just washed it with isopropyl alcohol, and I'll be ready to go. On closer inspection, I've actually found some factory dry joints. As you can see, there's actually a gap between the lead and the solder pad on a few of these. So I'm going to go over the board and correct any of these dry joints. Now while I'm working on this board, I'm actually going through every single fuse and replacing all the out of spec ones. I mean, the F111, which is actually related to this circuit here, was actually overfused originally at 7 amp, so it's got a proper 5 amp in now. This one here should be a 5 amp also. And it's got a big ceramic 10 amp in there, so that's not good. And this one here actually cracked when I tried to remove it. It's actually fractured, so a few there to replace. Okay, what we're going to do next is we've put the board into my getaway machine, and we're going to test the power supply out first. So what I've done is I've connected up the transformer inputs, but nothing else. So this isn't going to actually power any of the boards or the machine itself. What we're going to do is go through each of the test points and measure the DC voltage to make sure it's correct, and also check AC ripple as well to make sure that's correct. So that's the board powered up, and we're currently monitoring the 20 volt line, and we're seeing 22 volts unloaded, which is fairly reasonable. And as it's a true RMS meter, we can basically measure the AC ripple. Just give that a few seconds to settle down. Nothing smoking yet is a good sign, obviously. Right, we have absolutely no AC ripple at all. I mean, that is a very high quality, high ripple Panasonic capacitor, so that's pretty good. We're getting 5 or less millivolts of AC ripple, so that's really good. That's working fine. I won't bore you by showing each individual voltage, but I've actually completed that now and tested all the voltages, and they're all within spec. So we're going to catch up the rest of the boards and see if we can get a machine to power up, and then test out to see if the problems have gone away. Okay, so I think we're ready to power up now. Now we just have to hope that this mean nasty driver board does not destroy my sweet innocent getaway machine. So let's just get the remote to fire it up. Why is my DMD not working? That's not quite right. Okay, excuse the false start. I didn't have the 12 volt supply to the DMD connected properly. Let's try again. let's try again with the plug-in. I think this is going to be a fail video today, to be honest. Okay, now I'm trying again. Hooray! That's better. Camera's not overly happy with the brightness of that. Anyway, right, let's put it in test mode and see what's what. Let me press that. Let's go through. Okay, so the flasher test is currently running, and we'll just keep an eye on that for a couple of minutes. Oh, just noticed. Left ramp doesn't do anything. Yeah, I need to check if that's actually my machine's missing a bulb, or got a bulb out, or if that's the driver board. So I'll check that out again properly. So the coils are not working at all. So I think it's blown a fuse. Okay, we don't have anything on the 50 volt line, that's why there's no solenoid working. So I need to check that out. So fuse 112 is blown, which on the Adams Family manual was a 5 amp, that's what I put in. But on this game, it's a 7 amp, so let's put one of those in. Right, so I've replaced the fuse on the primary side of the power supply, and I've pulled out all the fuses for the solenoids on the secondary side. So this in theory should power up now without blowing the fuse and give me 50 volts on the meter. So let's give that a try. Okay, so we're seeing 73 volts unloaded, which is perfectly fine on this machine. So that is working. So we're going to connect one fuse at a time until we find the problem. It's fuse 103 connected and we're still fine. Fuse 104. And again, still fine. Fuse 105 connected. And again, it's still fine. 75 volts on the meter. Okay, and we're going to try again with the solenoid test. Just need to check on that diverter low, I'm not sure what that's supposed to do. Flashing lamp's working as well. Okay, so side's working, potentially diverter low needs checking. Let's do the flasher test again. Put it to run. Okay, those seem good. So I spotted a problem. If you look at the, some glare on that. If you look at the supercharger lamps, the middle one finds fine, right one finds fine, but the left one is really dim. You can barely see that light, so that's got a problem. So this is the transistor responsible for the flasher that's very dim. I've tested it in circuit and it looks absolutely fine. So I'm just going to replace it anyway, it's only a cheap component, so hopefully that might fix it. And the relevant transistor Q20 has now been replaced. And as you can see, the left flasher is now working absolutely fine. Let's play a few games to make sure this is working reliably and then it's ready to return to its owner. And a few games later, everything's still working absolutely fine. And I play one and it doesn't work. Anyway, this is now ready to return to its owner.